Did you know that most students fail math tests because they can't tell the difference between a relation and function? Today I'm breaking down the one rule that changes everything. Relations, functions, domain, and range. These words sound complicated, but they're actually super simple once you see the pattern. In the next few minutes, you'll learn the vertical line test, how to spot function instantly, and how to find domain and range without memorizing a single formula. So if you want to ace your next math test, stick around because we are diving in right now. Let's go. Hello, I hope you're doing well. My name is Mahmoud Yasser and welcome to Special K. So today we are going to talk about another interesting module which is going to be about the relationships, the functions, domain, and range. So at this point we are trying to talk a very important topic, which is the functions that shows the somehow relationship between inputs and outputs by considering special condition that we will talk about it, and also all of the related things to this one, like the domain, like the range, what are those and how we can find them, what are the inputs and outputs, and what is the general part, which is the relationship itself. So far we are trying to find a relationship with all of them, and also we are trying to talk about, can we use a test or the single test in order to see that specific thing is a function or not. And after that, we are trying to see what is the relationship between the relation and function. What is the vertical line test, or we call it as a VLT, why we use that, and what are the some kind of usage of the some kind of test in order to see that one specific relationship is a function or not. After that, we are trying to talk about the function notation, which we know it as f of x, and at the end, we are trying to talk about domain and range. So first things first, let's talk about it. What is relationship? Any set of inputs and outputs that we can show it as a pair of x to y is going to be considered as a relationship, the relation. And also it can be shown as tables, mapping, or graphs. And I have to say functions are going to be a special relationship. So what does it mean by special relation? We are going to see that in the next slide. We can consider all of the things as the relationship itself. But does it necessarily mean that can we consider them? But does it necessarily mean that we can consider them as a function or not by using some tests? So let's see some examples. I guess it would be better to understand rather than just explain it about it. Imagine that I do have a table at this point. I told you any pair of numbers, which we know it as x and y, x at the very first part and y at the second part, can be considered as relation, right? So imagine that my input is 1, and out of that specific input I do have a machine that is going to give me an output which is 3. So I'm going to show them with 1 and 3. Also imagine that I have 2 and my output is 4, so I would get 2 and 4, so on and so forth. So by using this table, I know that each input is going to be somehow related to an output, so we do have it as relation. Also, in the modulation wise, we can show that one. For instance, I do have 1 as my input, and my output would be 1 again. I have 2 would be 2 again. My output would be 3 again. And for instance, at this point, I'm going to add another example that my input is going to be output 4 again. So one thing that you have to be careful is the difference between the relation and function. Right now, we don't know anything about the function itself, but the relation means that I do have one input and I do have one output. So it doesn't necessarily mean that I can only one input and one output. I can have one input and multiple outputs. That is the point of difference between relation and function itself that we will talk about it in the next slide itself. So at this point, we found out about the relation. As I just told you, the very important difference between the function and relation is what is that the function is a relation that one input can be only map out to one output. So at this point, I do have every x, still I do have x to y. For instance, I do have my x as an input and I do have my y as an output. Every x maps to exactly one and only y. It means that if I do have a relation that again is going to act as a machine, that I do have x as 1 and output at 3 as 1. And if I do have 1 and again I do have 4 as an output, I say that this machine is not going to be a function. This guy is only going to be a relationship. So again, inputs can repeat only if they map to the same y. It means that if I do have 1 and 3, I can have another 1 and 3, but as you can see, still one input, one output. So real world idea, we can say that we do have a machine that it only had one result per input itself. For instance, we do have a function. Again, function is just like a machine that is going to get one thing as an input and is going to give me one thing as an output. So each input x only can lead to one specific output of y. So again, let's see an example that what is the difference between the function and relation. Again, any relation is just going to be considered as a general class. It means that any function can be considered as a relation, but it doesn't necessarily mean that each relation can be considered as one function. Like this example, as I just told you, each function is just like a machine, one input, one output. So in the very first example, we see that I do have 1 as my input, but my output at the same time is going to be 2 and 4. So obviously it's a relation, but it's not a function. In the meantime, I do have -2 and 2, which is not going to map out to anything, so that's okay. But I do have a 0 that's going to map out to 5, so I know for a fact that this guy is going to be a function itself. So some kind of simple test that we have in order to understand or find out that each relation is function or not is that something we call it as one line test or vertical line test. What does that mean? It means that I do have a graph, right? So when we are talking about graph, again, we are going to talk about it in future modules. When we do have a graph that shows the relationship between the x and y, by using one vertical line anywhere in the graph itself, I can understand that that specific thing or that specific relation is going to be considered as a function or not. Again, what was function? Function means that each input only can map out to one output. So let's look at this example. Imagine that I do have this curve. This some kind of blue one is going to be considered as a curve, which is a relationship. So a relation. So I want to know that right now this guy is going to be a function or not. So the only thing that I have to do, I can draw this vertical line anywhere. On that point, the only intersection between this line and this curve should be 1. It means that if I choose any x in this curve right now, each specific x is going to be considered as only one y itself, right? And maybe some of you would say something because it's completely obvious. I do have a point that two x's, for example, over here and here, two x's are going to be considered as one y. Again, it's not going to say that this is not a function. I told you one input, one output. But we can have multiple input that can have some kind of one output. That is totally fine. When I'm saying that multiple input, most of the time would be maximum of 2. On the other hand, we do have another part, or we do have another curve, which is the circle. And right now, I would like to see that if it's going to pass the test or not. So again, this circle is going to be my relation. I'm going to write a vertical line. As you can see, one input can map out to 2 outputs. So it's completely a fact and shown that actually this circle cannot be considered as a function itself. So let's look at another kind of example. Again, y is equals to x to the power 2. Again, how we can have this kind of curves or how we can make these relations is going to be a topic for the next modules, but let's just consider the way as they are. So I do have y is equals to x to the power 2. Again, I'm going to use that test. I'm going to write down a specific line or the vertical line. So as you can see, one input, one output. So that is good. On another hand, I do have this one. Again, write down the vertical line. One input can have multiple outputs. In the meantime, I do have the circle that we saw that this guy is not going to be a function itself. So for the very first one, we can say that this relation can be considered as a function, but for the next two, not. So after that, let's talk about reading f of x, because right now we know f means function, but what does it mean f of x? So as you can see over here, I do have a machine, but the name of the machine is f of x. F means a specific function, x means the input itself. So by using whatever input that I have, the f of x is going to give me an output which we know it as y. So y and f of x are some kind of same names or similar names. So f of x means when we need an output, when input is x, f is going to be a rule or is going to show a relation between inputs and outputs. Whenever x is input, y or f of x can be considered as an output. So let's talk about this example. F of x is 2x to the power 2 subtracted by 3x plus 1. It means that if I give you a number, for example number 1, and I ask you what is f of 1, the only thing that you have to do is just substitution method. It means that instead of just having x, put it at 1. x1, it would be 2 times 1 to the power 2 subtracted by 3 times 1 plus 1. And we know it from the PEMDAS. First of all, we have to do, there's some kind of, first of all, we have to do is the parentheses. After that, we do have exponents. After that, we do have the multiplication, so on and so forth, and we do have the final number. So as I just told you, the function is going to be as a machine, or it's going to be a rule. So the function rule is going to have a specific input and have a specific output, and this is the rule of this machine itself. So let's see an example. Let's see that how we can actually get an output out of that input that we have. So imagine I do have x is equals to negative 2 as my input, right? F of x is going to be a rule of my machine. Whatever number that I injected to this machine is going to be to the power 2 multiplied by 2 subtracted by 3 times that kind of specific number and plus 1. So if you do that step by step, you do have negative 2 to the power 2 is going to be the 4. And we have to multiply by 2. Step 2, we do have it as 8. We do have negative 2 again, should be multiplied by negative 3. So we do have it as 6. And 8 plus 6 plus 1 is going to be 15. So right now I know for a fact that my machine is a function. And if I give it negative 2, I can have 15. So let's see about f of 3. So right now I would ask you to stop, pause the video, and try to solve it by yourself. And after that, we are going to do it again. If you have any problem, please comment me down below, and after that, we can talk about it. So right now, I do have f of 3, right? So I would like to see that my machine is going to do what exactly with that number 3. So it's simple. I do have 3 to the power 2, subtracted by 3 by 2, plus 1. Again, we know, first of all, we have to do the parentheses, so nothing is here. So after that, we have to do the exponents. So we do have 2 multiply by, this is another form of writing down a multiply by. Most of the time you see it as like this, but in order to not getting confused with x, I'm going to write it down like that one. It's not very important. 2 multiplied by 9 is equals to 18. 3 multiplied by 2 is equals to 9. So 18 subtracted by 9 plus 1 is equals to what? Is equals to 10. So I know my machine is going to get that number 3 and give me 10 itself. So another way of, or representation of rule, the very first way that we understood was about the formula or algebraic formula itself. What was that? It means that I do have a machine that is going to do this one with my number itself. Another way that we do have is about the table that shows the output. This means that right now it's going to show you as pairs. So imagine that my f of x is 2x to the power 2 subtracted by 3x plus 1. So at this point, I do have negative 2 as an input. I do have a number. I do have negative 1, number, and so on and so forth. So by doing that, you can find 5 different points. That we do have it as x, and we do have it as y. So you can use all of them in order to have your graph shape and see the actual visual representation itself. So by this way, we can draw any relation or any function that we have. After that one, we have to talk about a very important topic that we had it actually in the fraction modules, that I told you that not all the time all the numbers that we do have as an input is going to be acceptable. It means that at some point we are going to face some problems. For instance, the very first problem is about 1 over 0. As we know, this fraction is not defined and we cannot consider it as an answer. So it is important when we do have a fraction, and in that fraction I do have a variable. That variable is a number that we don't know right now, and that the specific variable is going to be on the denominator. We have to find values that are not going to be acceptable, or the values that if we put there, I'm going to face the fraction like this. So we call that specific numbers that are going to be acceptable for us as domain itself. So right now, all x values, the rule accept. It means that we cannot have something that's going to lead me to division by 0. Square roots of negative numbers, as we know, square root of only positive numbers are acceptable. We do have some rules for negative numbers, but again, it is out of our some kind of knowledge right now. Maybe in the future we will talk about it. But right now we don't consider that whatever number, whatever x that is going to lead me having a negative value is not acceptable. Logs of non-positive numbers, which is about the logarithm, or another concept that we are going to talk about it in the future. But again, log of any negative number is still unacceptable. So we have the domain that is going to be all real numbers. So let's see an example that what does it mean actually. Imagine that I do have a function that is 1 over x minus 2. Well, I know for a fact that using the test, I know this guy is a function. So right now I'm only going to ask you what is the domain. Domains means that all of the acceptable values that you can use as an input. So at this point, domain is going to be all real numbers except 2. Why? Because if I use 2, I'm going to have something like this, 1 over 0. So it means that if I'm going to show you the visual representation of my x, it's going to be considered anything rather than the 2 itself. What about the square root of x? It means that when you do have the radical of x, only positive values can be there. So only values bigger than 0 can be acceptable over here. On another hand, we do have range. So when we do have the domain about something about the inputs, obviously we should have another topic which is about outputs. So we found out that the domain means that some kind of unacceptable laws or an acceptable condition that's going to lead me to some problem, so I cannot have them. They are forbidden. On the other hand, we do have it as y. It means that based on that the specific range or based on that the specific input that I do have for my x, how many numbers or what is the range of my output would be, right? So at this point, I do have all the y values or as f of x that the function can produce. So often read from the graph, and we can judge or use it just by our knowledge itself. Imagine that you have y is equals h to the power 2. So at this point, I don't have any problem with the range itself. It can be anything. It can be all real numbers, zeros, it can be anything. But for my y, I know for a fact that if I have a number, that if I multiply by itself, or if I use the power of 2, for sure that number is going to be positive or 0. So I know based on all of the knowledge that I have about the x, which is going to be any number, the output or my range or my y or my f of x only can be numbered from 0 included to the top. So if I also show you that in some kind of the drawing or the representation or visual representation itself, you can see that how we can have that number itself. So this line or this part is shown as a vertex. We'll talk about it. It's showing you this part is going to show you the range. It's going to show you the domain, and from this point to the top is going to show you the range itself. So y, the range is going to be any value from 0 to positive infinite itself.